Welcome everybody. Hope you're having a great day too, and hope you caught up on lunch. If not, please don't skip lunch. Today we're going to talk about JavaScript for Lightning components. We're not going to go really deep, but we'll see how in general JavaScript is used in Lightning components. Right? Before that, let me start off with the most important slide. You know what it is. I might make some forward-looking statements. And don't make your purchasing decisions based on what I'm going to talk about. Only make your decisions based on what's already available. So let's start off with where do we use JavaScript in the Lightning Component Framework? Well, you know, the Lightning Component Framework is the new framework that Salesforce uses for front end. Before going to where JavaScript is used, let's have a quick look at how the component bundle looks like. So this is a component bundle with a little description. We have a component, a controller. Component is where our markup goes in along with the HTML markup. And controller is where your JavaScript methods and actions go in. And helper is where you put all your reusable JavaScript, just because helper is accessible by everything else inside JavaScript. And style is where all the CSS goes. Documentation is where you write some description about your component for others to access. Okay, and renderer is where you define custom rendering for your component. That's again JavaScript. Design is where you add attributes to your component for the Lightning App Builder. Let's not go too deep there. SVG is just the icon of your component. Okay, so this is the overall bundle. And if you notice, the JavaScript goes into the controller, helper, and renderer. What is the controller for? Controller is where all the client-side methods are there to handle any events, any actions you want to take based on something. You write JavaScript inside the controller and call the methods in or out. And helper is where reusable JavaScript goes because any JavaScript methods in the helper are accessible by both the controller and renderer as well. So you don't need to repeat your code, just put it there and call it from there. So that's what helper is for. It's not a mandatory part of a component. It's a good practice, right? And then we have the renderer. Renderer is where you want to modify the default rendering behavior of the Lightning Component Framework. Lightning Component Framework takes care of rendering, but if you want to just tweak it a little, you do that in the renderer. We'll look at each of them. So what are some things that we can do in a controller? One example is accessing and editing and modifying component attributes. Any component has attributes, things that define that component. You can define any number of attributes or no attributes at all for a component. And if you want to work with those attributes, you do it in the controller, in the JavaScript. So that's one thing. And there's also handling actions. Like if something happens on the component, like somebody clicked on the component, what should happen? So this is where we put all the actions functionality. And also handling framework events. So events can be just a click or a mouse hover or something, but the Lightning Component Framework also has its own event mechanism. And you can fire events, you can handle events, everything using JavaScript, right? So all this is done through the controller. Let's look at a simple example, a very simple one. This is the markup for a sample component, and it has an attribute named text. It's a string type text attribute, string type attribute called text, and it just has we just gave it a default value, just a string, right? And we have another component there, UI button, which has a label. It just says framework button and menu, and it says press equals handle. So press is an attribute of UI button. It says if somebody presses on it, use the function, use the handle click function. So this function goes into the controller like this. Handle click, it takes in the component, event, and the helper as inputs, parameters. And we can define a variable and use the component API to get the attribute. If you look at the first line, it says component.get v.text. Text is an attribute in our view. So v dot stands for the component part, which is pretty much because it's a view, right? V dot is the namespace for all the attributes and all the available things inside a component. So you did component.get v.text will give you the attribute, store it in a variable, you can modify it, you can display it. Like we're doing a console log of the attribute value, we're displaying the attribute value which says just a string. So console will put a string in there, it says just a string. And we're also modifying this. So we're overwriting this attribute, the text attribute, with the name of the UI button. Right? We can just do like set it to just another string or something like that, but that's too mainstream, right? That's too simple. So what we'll do is we'll take the label of the UI button and put the label into the text string. So we do that by just getting the target source. So event is also passed into the function. So we have access to the event. And we have a getSource function which gives us the component which fired this event. Since you clicked on the UI button here, that is the component which fired this event. So event.getSource is the UI button. So you get that into a target variable and set v.text with target.get v.label. This is a simple way of manipulating accessing components and handling actions. And let's look at the helper. So in this function, all the code is in the controller itself. It's not using a helper. But you might want to have, for example, you might want to call Apex, right? If you want to call Apex, how do you do that? So you can do helper.update item. This is a function which uses the helper.update item, and you pass in the component and a few event parameters. The event has its own parameters. The default ones have default parameters. If it's a custom event that we create, it'll have its own parameters. And it's gonna call the helper's function, which is update item, which looks like this. And this is a mechanism of, this is a standard mechanism of calling Apex. We'll see further in that. But we put this inside the helper so that multiple functions can use this. So you don't need to actually write it again and again, right? It's a utility. So that is helper. And the next place where JavaScript goes into is renderer, right? So custom rendering only if necessary. That is because JavaScript, the Lightning framework handles rendering by itself. It does the bidirectional data binding and everything. So when anything changes, you don't need to like re-render your component and stuff. It's going to transform itself. But if you want to modify that rendering behavior, if you want to get into that rendering cycle, it is possible by modifying the renderer of the component. And there are 4 predefined functions inside the renderer that can be overridden. So if you write a controller, you can write your own functions. But inside the renderer, there are 4 pre-built functions. Only those can be modified. Right, the first one is the render. So render, if you modify the render, the default rendering behavior will be affected. And there's also re-render. When something, render happens for the first time and the component is called. Right? Re-render happens when something changes in the component. It has to transform into something, like when we change the attribute in the previous example. Right? So it changes the text on the component. So that's a re-rendering that happens automatically. And you can override that. And next is after render. Like after the rendering, if you want to do something. Right? And unrender. So when a component is destroyed when component is destroyed from another component which holds it, an unrender is going to be called because it has to take it off, right? So that's an unrender. And if it comes back again, it's going to be a render again. So this is the rendering cycle that can be overridden. And this is how you override it, right? So for example, I put all the 4 functions there just for illustration. It doesn't do anything though. It says, so the first line, if you look at the render function, the first line says where ret this dot super render. So that is like a necessary lines, right? So you can't create your own render behavior. You can only override, extend it. So you super render first and then do your custom rendering, like extending the rendering functionality. Same case with re-render, after render, and unrender. We'll look a little further in the renderer in the upcoming slides and the demo as well. Okay, we saw where it goes. Let's see a few hows. There is no limit to this hows, but let's just have a look at the most common ones. The first is working with component attributes, getting and setting component attributes, and the framework gives a couple of APIs or utility functions that you can use to do that. And what are they? This is a little example. Label equals component.get. We used this component utility in the previous example as well. You just need to pass in the component into the function, and you can do a component.get, and you can get anything, any attributes on the component. Now we're getting a label, and we're setting the label to something through component.set. So get and set are like the most widely used component manipulation functions inside the Lightning component framework. There are some utilities as well that you can use to check if it's an empty or if it's a string, stuff like that. There's a bunch of utilities available. One example is the $a.util.isEmpty. So this is like an available API. You don't need to check it yourself. You can just use that one. And if you want to just find something by an ID, find like in HTML, right? You get element by ID. Similarly, you can do a component.find and get it with the Aura ID. So Aura components have something called an Aura ID, which is slightly different from an HTML ID. But you can use that to find components and directly set the values, like you see in the example. Right? So this is how we usually do it. But we don't do this in usual HTML, JavaScript web development. But that's not recommended. This is what you should be doing. That will probably not work as well. So don't use standard JS methods. For example, these. Don't use a document get element by ID. Don't access DOM directly. Use the components framework, right? X.sum attribute, set attribute, get attribute. These will most probably not work as well. Okay, that's about working with attributes. The next is about handling events, Lightning way, right? So when you have events like on click, on mouse hover, or on scroll or something like that, right? These are called all the on events, right? So these on events can be wired to JavaScript action, which goes into the controller, or even the framework events, the events that the custom events that you create. Those also can be wired to JavaScript. Is a simple example of how you do it inside the component. On click equals handle click, press equals action equals, and stuff. Simple. And that handle click is something that goes into the controller. Don't include direct JavaScript inside the Aura markup because it won't work. For example, if you look at this, it has direct JavaScript inside the on-click attribute. Right, alert, this will not work. Any guesses why? Because it will not work. That's why it says it will not work. So it will never appear. It will never get alerted that way. This is about handling events. Don't use JavaScript directly. Just hook it up to action inside the controller. All right, so we looked at attributes, events. Let's just look at some dynamic behavior. For example, conditional display, right? So you want to show or to not to show. You're still thinking, should I show or not to show or not to show, to be or not to be. You can use the general standard practice of CSS toggling. So CSS toggling is a way of showing or not showing a part of markup based on the CSS class that it's using. So you probably can do something like this. If you look at the bottom, there's a toggle.css. It says display none. And when that class is being used, that part of the markup or div will not appear. As simple as that. Right? So you can probably have a toggle button. It says, now you see me. And if you click on it, it will probably be gone. Right? Because using $a.util.toggle class, which is a very handy util for toggling the CSS classes that a component uses. So we just did a component.find with the aura ID, the p tag. We got the p tag, and we are toggling the class of the p tag to the toggle class so that it will just disappear. So if you keep clicking, it will keep appearing and disappearing. That's all it does. And there are other classes as well, not just toggle. You can have add class or remove class, but toggle class has a combination functionality. Well, so it will either add or remove based on what's the current state. And we also have another option in the Lightning Component Framework, the aura if tag. You can still use it, but toggling CSS is the simplest way and the most standard way as well. Right? This is a little example of the aura if tag. Aura if is true, just check for the attribute. If it's true, check for a condition using the expression language. If it's true, show it. Else, you can't edit this. So that's what you're going to display. This is the standard way of using aura if. But using JavaScript, you can do CSS toggling. Okay, dynamic components. So you've displayed stuff conditionally, but now you're adding components conditionally. Right? So you get to decide whether a component is part of another component or not. So for that, we have a very handy function called create component. You just need to pass in the type of the component and the attributes, and a callback function which will be called when the component is created or rendered inside. Little example. This is just a very simple boilerplate. It doesn't have anything, but there is a body attribute that we're using there. Right? So this is like a default attribute that you can directly use. This body attribute by default does not have anything. But if I create a component using my JavaScript, I use $a.create component and pass in the component name, UI button, and parameters. I pass in an ID, pass in a label, what appears on the button, and what happens when it should press. I can just directly give a reference to a different function that is there in my controller. And followed by the callback function, which takes in the created component. This is the component that is created. And we get the body and push it and set it. So the body will now hold the new component. This is how you create. You can remove them as well. We'll have a look at that in our demo later. Okay, we saw dynamic components. Let's also look at rendering in the DOM. So we spoke a little about the renderer previously. Renderer is when you want to manipulate the default rendering, or you want access to the actual DOM, right? It's still possible. You can access the DOM, and you can also have your own behavior. For example, I have a little alert here. This alert will actually appear before while the rendering is done. Right? So this is a way of figuring out where the rendering falls in the whole cycle, right? So there are a few caveats of using the renderer. You should not really fire events, because when you fire an event, it might cause a re-render, and that will again call this render, and you fire an event again, it calls again, fires again, calls again. It doesn't end, right? It doesn't know where to end. It's not that smart. With Einstein, maybe something will come up, but right now, no. Yeah, so don't fire events and don't set attributes, because setting attributes will also cause re-rendering. When you set a new attribute, the component has to be re-rendered, right? You don't want to take that risk. This might also result in finite loops. Use the controller instead. Don't use the renderer for setting attributes and stuff. Use it only if it's absolutely necessary. And only modify DOM that belongs to the component. Don't sneak into the neighboring component that's there, right? So don't steal. Speaking about that, this is only for now, because when something called locker service comes up and it's enabled soon, you won't anyway be able to access DOMs from outside your component. So that's what locker service is, a bunch of security best practices that's been enforced on the framework. The first rule is a component can only traverse the DOM and access only elements created by that component. You can't really reach to another component. That's one rule which will be enforced when locker service is enabled. Another is you can only use published JavaScript APIs. Examples of JavaScript APIs are the create component or $a.util. These are the JavaScript APIs that the component framework gives, Lightning component framework gives. And previously, there were functions which are not documented, or utility functions not documented, but they were still working. When locker service comes in, that will not be the case anymore. Right? You can get the documentation of all the functions and utils available, and this is all you get. That is also because Aura is an open source framework, and it has a lot more other undocumented functions that will work, but Lightning will not let that happen because they're not undocumented and they're not foolproof. Right? So they'll probably not work the way you want them. And also JavaScript ES5 strict mode is what you're going to write your JavaScript in. Right? ES5 strict mode is implicitly enable. You don't need to write use strict or something like that in your JavaScript. It's already there. Make sure you're writing ES5 compliant JavaScript. And just to make it easy for you to make sure all this is taken care of in your Lightning components, or if you want to just check it or something, we have something called Lightning CLI, which is available. It's a command line tool, and if you're using Lightning components from Eclipse, or you have a local component file stored locally, you can run the CLI and it will lint the JavaScript for you. It will check if the JavaScript is compliant with the locker service, because locally you won't really get to know, right? So this is locker service, and Lightning components are front end. It's a front end framework. And if it ever has to access data, right? For example, we saw the callback that was action that we were sending to get data from Apex controllers. So to get any data, metadata, or call any external API, or make a REST call or something like that, we should use Apex at present. And with Winter 17, we have some base components coming up which will reduce this, but everything else has to go through Apex, right? This is a simple demonstration of how to do that. You have a myObjects attribute, and it's an array of a custom object called myObj_c, and we iterate through the myObjects and stuff. And how do you retrieve myObjects? That is through using the action utility. Just get the method. So if you look at the top, the controller says myObjectController. That is an Apex controller. And getMyObjects is an Aura-enabled method inside the Apex controller. And you set up the action, set up a callback, because any calls to Apex are going to be asynchronous. And you have to set up a callback so that you're not really waiting for that thing to happen before doing anything else. We don't like waiting, right? So you set up a callback and do anything with the response, do anything you want with the response. For example, you're setting the attribute with the response of the Apex class. And set up a callback and enqueue it. $a.enqueue action is the API they use to enqueue any Apex requests that you have. And the Apex class looks like this. Public with sharing the class name. @Aura-enabled is an important annotation because that's necessary for Lightning components to use Apex methods. It just returns a SOQL query, just returns an array of a list of myObj_c records. With that, let's have a look at what we saw in a demo. Okay, I have a little component added here. It's just a component tab. Just says I'm rendering. It has a show hide button. Let me make it as big as possible for you. Okay, so it's just a button which says show hide. If I click on it, it shows a bunch of contacts from my records. And there's an option to create a silly button if you're interested. Click on create a silly button, it just says, I got created, click to hide me. So this is an example of dynamic component creation. And this is an example of CSS toggling, and we have an example of calling the controller and stuff. Let's look at what it looks. Let's see what it looks like. Let's look at the code. Okay, this is our sample. Here's the bundle. Let's go into the component. And can you see the component okay? Okay, so our component has an Apex controller attached to it called sample Apex controller. And it has an attribute called sample contacts, which is an array of contacts, right? It's a contact array type. And it has a little handler, which is called the init handler. And init handler is an event handler that is provided by default by the component framework. So this can be any event that you create, any custom event, or it can be the default one, which is init. So this is fired when a component is initiated for the first time. So what we say is when you init, do something. So when you initiate a component, perform an action for me. And what does that action do? That's there in the controller. In do init, it says helper.getContacts. Right? And I'm passing the component. And helper has a getContacts method, which does a call to Apex and returns the response and sets up the attribute with the response value. So that's the helper. And we're also registering a simple sample event. It's a custom event that I've created. When you create an event, you have to register it inside the component and fire it. So I registered it, and I'm actually handling it in the same component. This is not ideal. For demo's sake, we can do pretty much anything, right? So that's why I did. Okay, so this is supposed to be in another component. It's going to handle that event, and that is how component communication happens. So just for demonstration, I have it in the same component, and this is our button that says show hide, and it has a little functionality when you press it, and it says fire toggle event. Go into the controller. So fire toggle event is going to get the event that I've created or registered inside the component. It will get it and fire it. Component.get event is again another utility of the component API. You get it, you fire it, and it has to be handled, right? So this is action that happens when that event is fired and handled. Because we have a handler, it's going to handle it itself. It says toggle display. Go into the controller, toggle display. It's using the toggle class, which will change the CSS of that particular div, which is button. We are getting a component called button, which has an ID of button. Finding that, and we're setting up the CSS of that to hide. Now, what does hide have? It's in my style. Hide just says display none. Just make it disappear. Now let's look at the button div inside our component, whatever we are getting. So this is the button div, and it has an iteration of all the contacts that we just received from the Apex controller. And it has an iteration variable contact. Each iteration, we are displaying the contact with a little link, right? So there are two ways in which this link is, there are two actions that can happen when you click this link. One is the standard href. It says on click alert. This will not work, just not because it says I won't appear, it's not in the mood or something, but it will not work because you can't use JavaScript directly inside the Aura markup. This will work because it's wired to an action. If you look at the show alert controller, controller action, just says alert I will appear. Let's see if it actually appears. If I click on it, it says I will appear. The I won't appear thing did not appear. Okay, let's go back to a component now. Now, we also have a little conditional display section. This is going to be displayed when you click on show or hide, right? It will appear or not, it won't appear. And there is also a button that we added, right, to this conditional display. It says create silly button. This is going to create a new component when you press this button. It uses the create dynamic CMP function. You go into the controller and check for create dynamic CMP. Creating a component here. $A create component. Let's create a UI button component which has these attributes set up this way, and the callback function to to add it to the body of the component. Right, and this on clicking is going to call the hide dynamic CMP. That's why it disappears when I click on it. This one is just using a add class function. Hide dynamic CMP is using the add class function, which adds a CSS class called hide to this component. Let's just have a look at the demo once again. Show hide, create silly button. I can actually create multiple of them. Keep going, keep going, keep going. It's a little work to make them disappear though. It's not much. It's okay. Just need to click on it, it goes away. Makes life easy for me. Show hide, alert, I will appear. And if you noticed, when I actually access it for the first time, it says I'm rendering. I have a little alert inside my renderer, which is actually overriding the default render behavior. It says do a super render and send an alert. Alert is not doing anything, but you can pretty much do DOM manipulation and access the DOM and stuff like that in this. And with that, we're back and we are done, and I'm open for questions. Yes?
Can you publish your slide there?
Yeah, I can do that, yeah. All the slides are going to be published anyway. Yeah. Yes? So the best performance comes from toggling CSS, because you're not actually rendering or re-rendering. You're just deciding whether to show it or not. It has the best performance. And Aura if you want, it has pretty much the same thing. It's just a feature that's there. And if you want your component to have multiple facets, right? The component has to transform based on particular attributes. So you can use Aura if for that. You can just set up an attribute and it'll appear. It's an easier way, a shorter code of doing it, but it does the same thing. But see, toggling CSS is faster. And the other is dynamic components. Though it looks a little similar, it has a different use case. You have to create a component based on particular use cases. And when the component is not created, it loads faster. So you get to create a component only if it's necessary. So if you don't need that component, don't make it dynamic so that initial loading will be faster. And when you need that component, only then it will appear. Get it, friends?
So I'm curious to understand your thought process on how they actually send like a huge blob from the Lightning component
Yeah, so the bottleneck is the Apex limit, so we need to take care of that. So we have to do it within the limits of Apex.
And do you have any thoughts on when they would open up to directly access the APIs instead of actually relying on Apex to send some data and then you can go from Apex back into other web services? Or like what is the current recommended practice that
Yeah.
you want to do? So for example, file upload, we are constrained with only like 4.3 MB to pay payload, even the chunking. So any thoughts on how to achieve that?
So his question is, how do you handle file uploads and calling external APIs when Apex has its limits, right? So one way is to use the file of the new files object, right? So you can use files, but you can actually use it from an external API instead of Lightning Components. Lightning Components is mainly for the front end. It's not a fully fledged framework for all kinds of functionality. So it can do something, it cannot do something. Yeah.
How do I make a non-Lightning application communicate with the Lightning application? The use case is I have an iframe inside of a Lightning component which displays a non-Lightning application that wants to send messages using pure JavaScript to the Lightning component.
You can use it using the renderer because renderer will give you access to the DOM. You can directly reset. Did that answer your question?
Right there. So if I have an iframe sitting inside of a Lightning component, how do I make that iframe send JavaScript messages to the Lightning component?
It's a good question. I don't know the answer. Yes.
In general, we're doing a Lightning launch, and in general, we're seeing latency rendering our sales cloud. Is there a way for us to diagnose whether they are actual platform latencies or is it something what's the best way to diagnose? I don't know how many people
I think the best way is to find the fastest connection and check if it's still the same problem. That's usually the case with Lightning Extreme because it's a single page application style, right? It has to load a lot of stuff. But if you're still seeing latency after initial load, and when you try to access something, and it's because the initial load will be slower because it has to do a lot of cache. So once it does caching, it will be a lot faster. If it still has that issue, it's something you need to bring to our notice. We have the known issues, ideas, Salesforce support, different, or through your account executive, to your CSM, customer success manager. Yeah.
it's not going as fast as
Yeah, okay. You have the idea exchange, and known issues are usually well scanned by the R&D team directly. You don't need to go
Yeah,
through.
but I was just wondering if, there was a Chrome add-on that shows some of the calls that are being made and the latency was really useless. I was just wondering if you had any strategy.
No. It's not exactly the framework problem. It's the application is pretty heavy. It's going to get better. It's still evolving. It is going to get better. Otherwise, it won't work, right? So when they know it won't work, they'll do something about it. Sure. All right. Thank you so much.